Hello, welcome to AT&T ThreatTraq for October 29th, 2013. This program provides network security highlights, discussion, and countermeasures for cyber threats. I'm joined today by Jim Clausing and John Markley. I'm Brian Rexroad, and Jim, let's go right to you. As if the domain name space hadn't been kind of complicated enough, I guess there are a few new ones coming.
Yeah, Brian. We've known for some time that there were going to be some new top-level domains. ICANN approved the idea of a bunch of new top-level domains, especially for non-Latin alphabets.
Mm-hmm.
So the first four of those are finally now open for business. For the first 30 days, there are restrictions. Well, actually, for the first 90 days, there are restrictions. So you can't just go out and register Jim dot whatever this new domain is yet. But they do exist, and the first four are shown on this slide. The first one is in Arabic, and that Arabic word stands for either web or network, depending on who you talk to. The next two are Russian, Russian for online, and then a Russian transliteration of the English word site. So it's pronounced site, but it's spelled that way in Cyrillic there.
Mm-hmm.
The fourth one is Chinese for game or games. What you see in the parentheses on this slide, though, is probably interesting for those of us who run DNS servers. This is the Punycode translation. Punycode is described in RFC 3492 for translating non-Latin character sets encoded in UTF-8 into ASCII. And ASCII is actually what's probably going to be sent back and forth to your DNS servers, your recursive DNS server that's looking up something in this new domain. What you'll see in your DNS logs will be this XN-NGBC5AZD, whatever. A colleague of mine went ahead and did a dig on this domain to show that, in fact, the root DNS servers are responding to queries for that domain. And as you see here, it's that Punycode translation, and it returns a start of authority record. So we got new DNS top-level domains coming. These first four, for the next 90 days, there's not really going to be anything answering. No domains or no hosts registered in these domains are going to be responding. But they're coming, so you need to be ready for them.
Okay. Now, I'm a little curious about this because obviously when these get translated out into the ASCII format, they're quite a bit longer than the traditional domain names. And surely if, the child domains or the subdomains associated with these are encoded in a similar way, you would expect, commensurate extension or elongation of the domains. Were any adjustments made to accommodate the longer domain names?
I'm not aware of any adjustments that were made. Some pieces of software, some web servers or whatever, may have artificial limits built into them that, or other sorts of software that looks at domain names and says, what's after the last dot can't be more than 4 characters. Well,
mm-hmm.
that's an artificial restriction in the software itself that clearly, if those kinds of restrictions appear in software, these new domains are going to point those out to us because they're going to break things.
Right.
One of the big issues that I see is that even what would be a relatively small, third-level host, domain, host name, whatever, could become quite large. And we've seen, I'm just thinking of the possibilities of DNS amplification attacks trying to take advantage of stuff like this, where you get really long responses because now the domain part is long, and then the second level domain is long, and the host name could be really long.
Yeah, that's a possibility if you have multiple responses or CNAME responses, that sort of thing, taken as the request.
I could also see some programmatic issues where you're looking for certain domain names, org and com, and security programs are looking for those, or even non-security programs may say, this doesn't match any URL, so it may ignore it or not even recognize it as a URL.
Yeah, sort of a legacy, perception of how domain names should be structured. And I guess the other aspect of this, and Jim, you kind of alluded to this, I think, is the, some algorithms have been developed to look for what appear to be machine-generated domain names, and one of the motivations behind that is some of the things like FastFlux will use machine-generated domain names, or I guess it's the DNS FastFlux, will use machine-generated domain names and other campaigns as well to help diversify the domains and kind of get in front of what protection measures could be used. And clearly, you wouldn't want to mistake these as machine-generated. They're not machine-generated; they're just encoded.
Right. Yeah. Conficker was the first one of those that we all remember had the domain generation algorithm built into it, where it was coming up with all of these randomly generated domain names and then trying to register a few of them. And so a number of people built the algorithms to look for things that might potentially be machine generated, and now we definitely need to be aware of the encoding versus the random generated type of names.
Right.
Absolutely.
All right, very cool. And I guess this isn't the only kind of encoding that we have to deal with, huh?
No, I came across this one actually a couple weeks ago, and since we were talking about the new domain names that are non-ASCII, it reminded me. A friend of mine, Harlan Carvey, did a blog post over at Dell's SecureWorks research blog on detecting malware that uses Unicode to hide itself. We've talked a couple of times in the past about the right-to-left overwrite encoding, where you could you stick the Unicode character in there, and then you essentially back over the part of the file name, and you can hide extensions and such that way. Malware has done that from time to time in the past. And what Harlan was taking note of is there are times when, obviously you're not going to be able to see it if you just have your Windows desktop up there and you're clicking open folders. The right-to-left overwrite will just basically back over and replace the characters, and you're not necessarily going to see it. So he was talking about how an incident responder or a forensic investigator, how you can detect this kind of thing, and potentially generate reports of weird new names that have these Unicode characters embedded in them. Mm-hmm. And so I thought it was worth remembering. We have seen instances where taking advantage of these Unicode characters, the bad guys have tried to hide. Generally, they tried to hide the file extension, but sometimes they try to completely change the name of the file. So I thought this was another good opportunity. Harlan in there does show how some of the popular forensic tools show how they behave when they encounter these Unicode characters in there. And he has a plug-in for his Reg Ripper, which is a tool that is the must-have tool if you're going to be examining Windows registry hives. And he's to detect when this right-to-left override character shows up in a registry key.
Right.
Pretty cool. So it's a good plugin. I hadn't had it before, so I'm going to go grab it now and make sure I include it in my toolkit. So.
Good. Yeah, I was looking over the article here. He goes into, I know, as you referenced, John Hogaboom in the past has shown how this technique is used oftentimes to mask a file name, oftentimes in email messages to try to get you to click on it. And so he's looked for this. This article actually goes into a lot of detail on how things look and how to analyze it. So probably a good article for folks to take a look at if you have an interest in that area. All right, thanks, Jiv. And I came across an article just recently that I think provides a little bit of a new and different perspective of things. So I thought I'd share with you. It turns out this article isn't new at all. It's actually from January 30th, 2012. So, but regardless, the article was out there. This particular perspective was kind of new to me. And what it's talking about is basically an ARP spoof attack. That's the address resolution protocol that basically a student had admitted to performing on a school network. And the two things that I wanted to share with you about this is, first of all, we don't often talk about Layer 2 attacks. And so this is one that I perceive at least as a Layer 2 attack. That is, it's prior to being able to actually address IP layer packets. And so it's in the process of trying to basically translate an IP address to basically a MAC address or a hardware address that you can send packets to. And so the spoofing technique is associated with that. That is typically on a local area network. You're not using a routing protocol to route things. You're using basically ARP to do that. And basically the way this works is, when somebody has a packet, a device on the network has a packet that it needs to send, it's going to say, well, who's the owner of this address? I'll send it to you to your hardware address. And so the ARP protocol basically facilitates asking the question and getting the response. And typically, the devices on that network are going to cache those responses so that they won't have to continue to ask the question. And one of the problems that can exist is that devices on that local network might cache responses even if it didn't ask the question. So that provides an opportunity for somebody to perhaps basically broadcast out responses, ARP responses, that may be actually false in nature, to say, I'm the holder of this address and the other address and a number of other addresses on that network, and it provides a way to basically redirect the traffic and perhaps conduct a man-in-the-middle type attack. And obviously that would be consequential. And so what this person did was basically ran an ARP spoofing protocol on an Android device on the local network and was able to redirect traffic. So the two perspectives here, first of all, to keep in mind that there are possibilities of Layer 2 attacks. And the second one here is that mobile devices actually do provide sort of a we'll call it a medium or a device that could be used in the context of internal attacks. We've oftentimes talked about devices perhaps being victims of attack. But here's a case where by allowing them or bringing them into work environments, for example, they could perhaps be used in the context of being able to target that local environment. So I guess another sort of justification or rationale for protecting the local networks, the Wi-Fi networks, for example, to protect against that sort of thing.
Yeah, and ARP spoofing attacks, are can be difficult to protect against. There are, some switches that have some fairly decent protections against it, but if you really are on a shared Ethernet segment, then you're in trouble. And if you're on a wireless, you are susceptible to whoever responds to that ARP first. Aren't necessarily a whole lot of protections if you're on a wireless. Fortunately, with IPv6, it's all moves to layer 3, which doesn't actually solve the problem, but it's...
Right. Yeah, there are a few things that can be done here, but it's not going to happen by accident, much like anything else that's security related. I guess I did a little bit of reading, actually, just some preparation for the program here as we were discussing it. I guess not all operating systems have this problem, and some of them can be basically facilitated to help protect against that sort of thing. That is, to not cache responses unless it actually asks for the request. That doesn't solve the race condition that you alluded to, but it could solve somebody just broadcasting responses and running the risk of end devices basically caching those responses and believing those. And, another, from an analytical point of view, you could look for inconsistencies. That is, if one device is responding with one address and another device is responding with another address, you might be able to pick up on those inconsistencies. Or I guess what I should be saying is that if you have multiple hardware devices claiming that they're the same address, that would be a sort of a flag to consider. Maybe not, raising that as an alert on a system. So there are software tools and things that can be used to detect this sort of thing, but as I said, it's not going to happen by accident. So you want to perhaps consider at least areas where you might have that sort of risk, a non-trusted environment, that you want to make sure that you don't have that sort of spoofing. It's just another perspective that we should be keeping in mind. All right, and I guess let's talk a little bit more about mobile devices, but perhaps a little context here. John, I guess there's another iOS patch out encouraging that they're staying up on the patches. What can you tell us?
Yeah, and Brian, that's a good point. Is that we want to stay current with all the versions of Apple iOS that. And then any product you have out there running, we stress, maintaining security patches. One of the challenges that Apple and other vendors are having in the mobile world is that the devices that we carry in our pocket, ubiquitous to all of us, we rely on them for so many more things over and over and over again. We want to use them for emergency calls. We want to use them. A deer runs across the backyard. You think, oh, that's cute. I'm going to go take a picture of it. So you want those quick access functions, either for personal security or just for ease of use. But then we also want to lock the device. And so it's kind of a trade-off. And so what a lot of the vendors are starting to do, and you see this, like I said, in almost all of the mobile devices, is that they have some functionality that happens before you unlock it. Some neat things, take a picture, make emergency calls. Those are things that happen early. What, unfortunately, the vendors are finding out is that if you allow, individuals and groups, certain functions before the device is unlocked, you may be opening up things that you didn't realize you've opened up. And Apple's been caught with this a couple times in the last few years. So, and so is all the vendors. I don't want to just pick on Apple here, of course. But Apple did release a patch. I think they've been very good since iOS 7 came out. They've released, this is the third one after that. And this fixed 3 of those type of issues. 2 were for passcode access, or passcode lock issues, and 1 was for, being able to get to the dialer and actually be able to see the contents of the contact list as well as to make phone calls. So there's some other things in iOS 7.03, but from a security context, these 3 patches or 3 issues are corrected. And, of course, we recommend that, individuals start loading this as soon as possible if they haven't already.
All right. Yeah, I think, one of the things I did notice about iOS 7, and this is not what I would describe as a professional analysis here, but there certainly are a lot more features in terms of being able to turn on and off things that might display on the device even though the device is locked. as well as you were alluding to earlier, being able to get access to features or applications even though the device is locked. And so there are a lot of little subtleties in that, and it's a pretty tricky business about, can you do this under the circumstances where these are exceptions to that? And it reminds me back of the, when computer security was really basic, the Bell LaPadula model, which was very basic in terms of the rules. And then they kind of did a sort of a glossy thing that said, well, everything else is an exception. And then ultimately, all the security problems come out when you start, putting all of these exceptions together and dealing with it. So where was I going with that? Fundamentally, I wouldn't be surprised if there are other cases like this. It's going to be tricky business going forward, trying to allow access under certain circumstances, but still protect the data that you want to be private. And
I think it's a never-ending struggle. Like you said, it's things that you want to do. The Control Center in Apple, you have the similar type things in Android. You want to have those features that are quick and handy to use. And, you got to recognize that whenever you allow anything before the password's done, you've opened up a security issue.
Right.
Or potential.
Well, not necessarily an issue, but certainly,
potential.
It makes it more complicated. And I guess the other aspect is my recommendation is go in and pay some special attention. iOS 7, as I said, has considerably more settings that the user can control, and you want to take a look at those and make sure that the things that you prefer to be allowed to be exposed are the ones that are actually exposed. And the tricky thing is you can't be thinking about how you use it on a day-to-day basis necessarily. You want to think about it when somebody has it that you didn't expect to have it or want to have it in the first place.
Yeah,
that wasn't a statement of obvious, perhaps.
Yeah, well, and as John said, Apple has been really good at, as soon as they're made aware of these issues, they've been fixing them especially since 7 came out. So they're fixing these issues.
Absolutely true. All right, well, let's take a look at the internet weather for the last week or so here. And top of the list is an event that, wasn't really atypical of what we typically see. This is scam probes on port 6666 TCP. And when I went to investigate this a little bit further, it was a single address that basically traces back to China that was doing the scanning activity. Did a little more digging, found that there were a number of other ports, and these are just examples of those ports. Port 192, 1998, 6080, 6670, 9895, 8048, 8088, and 12883. That's kind of an array that I'm not sure how to associate those with specific applications. It may be that you're just looking across the broad spectrum of things. And what was kind of interesting about that is basically when you look at the aggregate of that activity together here, showing in the graph, you can see the spikes of activity associated with the port 6666 TCP. But you also see a very sort of methodical set of activity that is essentially sequencing through these other ports. Each of these colors represents activity on respective ports. So they're basically walking through it, makes a nice little rainbow on the graph here, and you can see it basically repeated about 2 weeks apart between the events. So chances are, if we were to dig into this further, you'd see this address probably walking across a number of other ports in this space in between here, and it's just kind of going through that regimen regularly. So you'll probably you might be able to identify the specific address in your analysis, and perhaps you don't want to hear from that address if considering it's just continually probing around. Next one here is scam probes on port 1502 TCP. It seems like we've seen this, and that's associated with VNC, the virtual network computing. It's one of the alternate ports, and if I understand correctly, the default port is port 5900, but if that port is occupied by another application or there's already an instance of VNC running, it will walk up, that is the server side of it, will walk up through to 5901, 5902, 5903. And so what we've been seeing more recently is more scanning activity on the on the other ports. 5900's scanned frequently, but we also see 5901, 5902 showing up more recently, or more frequently recently, I should say. And so in this particular case, we see that over the last week or so here, basically some relatively low level, but relatively continuous scanning activity on this port 5902. And that basically is associated with a particular one address in the United States. It appears that machine might be an infected server associated with a otherwise legitimate user. It's that I'm not really clear on. But ultimately, that particular source is also being seen scanning on other ports, 4899, for example, which is associated with the remote administration protocol, and also on 5901 and 5900. So it's pretty clear that this one is targeting and looking for remote administration access. And in fact, the server that's doing this may have been a victim of that sort of attack itself. Next one here is scan probes on port 5038 TCP. We hadn't seen this, or at least it hadn't showed up on the weather radar in recent memory over the last couple of months, I would say so. But it is associated with the asterisk voice over IP management protocol. That is, we typically see this trying to target VoIP servers, perhaps to be able to gain access to those. Two options might exist here. One is it might be a gateway or used as a gateway into an enterprise. The other option might be that they're trying to get access to VoIP platforms so that they can perform toll fraud activities. And yes, there are certain places where you still have to pay to get access to them, so toll fraud is still out there. And in this particular case, I've seen probes from a variety of different addresses over time, but it seems like there's most of them that show up are located in the Netherlands, a variety of addresses there, and then also sometimes the United States. And this isn't particularly aggressive activity. It's not consistent. There's spiking here and there, and there seemed to have been a lull for a couple weeks in the early part of October, but we see those spikes picking up again. Looking at the most probed ports pie chart here, no particular surprises. We see port 53 UDP, as we've talked about. A lot of that seems to be associated with DNS reflection attack activity. That is, the query side of those requests has the tendency to look like scanning activity in the probe in the analysis. We see port 445 TCP on the list, port 1433, that's Microsoft SQL database, port 80 TCP, and port 22 TCP, that's SSH. And, of course, we see the peer-to-peer ports associated with the zero-access botnet. We'll take a quick look at that in a moment here. Then in terms of the most sources doing the probing, no particular surprises here, very much the same as we just talked about. Port 445, port 80 is on the list, and then port 23 TCP shows up here. So, it looks like there are more sources that are probing for port 23, but more probes actually going out there for port 22 from the previous graph. And then when we look at zero-access botnet peer-to-peer activity, this has sort of become a regular part of the program, partly because of the aggressive growth that we've seen on this particular botnet. This week I decided to show 365 days. Over the last year of activity, we were looking at 180 days in the past programs. And it gives you a little bit of an idea of where it is today relative to where we had seen it basically in its peak. So back in February time, actually it was in January timeframe, late January, early February timeframe, we saw a peak of about 110 million plus basically events picked up in this activity. And most recently here, and this is actually a graph picked up from yesterday, we're just a little bit above that, up around 120 million events on in the measurement period here. So it appears that botnet is actually a little bit stronger than we had ever seen it before. And as I mentioned, since, around the beginning of September here, there was certainly a significant and aggressive growth in that botnet, of recovery from a takedown activity that had taken place back in around the middle of July or so.
I don't know what the 4 different ports are used for, but one of the things I've been noticing, comparing the current graph with, back 9 months, a year ago, is the red and the blue ports there, the 16465 and the 16470, are larger than they've ever been. The green is about the same. The yellow is actually down a little bit from when it hit that peak last January or February, whenever it was. Well, what those 4 different ports, what the difference is between them, but I've been watching that for the last few weeks.
Well, that's a good question, Jim. I hadn't really analyzed that aspect of this. I think we'd have to go to somebody that's analyzed the details of the malware. Perhaps that's something we can take up as a question to answer for ourselves in the next program. But I certainly don't have an explanation. Good question. It may have something to do with a fairly random selection of ports and how they're selected. But I don't think there's a fundamental difference between what the ports are used for, other than there's some selection criteria that's used. Okay, so that's the program for today. And if you'd like to get in touch with us, you can contact us through email at threattrack@list.att.com. You can also follow us on Twitter at ThreatTraq is our handle on Twitter. The ThreatTraq video program is available on the AT&T Tech channel. You can go to att.com/ThreatTraq, and it's also available on YouTube if you like. You can subscribe to an audio-only version of it on iTunes. And I would like to thank you for joining us today. Thank you, Jim and John. I'm Brian Rexroad, and we'll be back next week with a new episode. Until then, keep your network safe.